Lessons from nature. Are there responsive solutions in the natural world that can help form architectural design features to tackle the rising climate extremes in the UK? So my presentation will be split up into three sections, and we're going to be starting off with section one, which is establishing the climate issues. So we all know we're in a climate emergency, but in the UK in particular, we've seen the highest ever recorded extreme temperatures. So in 2022, we surpassed 40 degrees for the first time ever. And we've seen 7 out of the top 10 temperatures ever recorded being in the last 20 years, which means that 40 degrees is looking to become just as common as 32 degrees is today by the year 2080. So if we again look at a map of this, in 2023, we look at the temperatures being above average across the UK for the summer. But then if we then compare that summer again to 2080, we're seeing again another significant increase in summer extreme temperatures. So if we then look at the actual recorded data and modelling between 1981 and 2000, we didn't actually see any temperatures go above 38 degrees. For the models between the current quarter that we're in, 2021 to 2040, they're predicting that we'll have 1 to 11 instances between that surpass 40 degrees. And considering we already had one of those in 2022, it looks likely that we're going to fall somewhere in between that 1 to 11 range. But then what's quite scary is that we look at 2061 to 2080, where 41 to 141 instances above 40 degrees, which is kind of really establishing the issue that we're going to be facing in our environments. But why is that an issue for architecture? I mean, if we look at the city of London as an example, the high-rise glass typology often can take on a sustainable strategy that is quite static. So it will look at kind of static solar shading, or it might look at how we can reduce the amount of energy it needs to deal with cooling loads. And if we look at cooling loads in particular, though, for the year 2000, the cooling load needed for a typical typology of this in London would be between 30 and 40 kilowatt hours per meter squared. But we're looking at that increasing by over 50% by the year 2050. So maybe looking at reducing the energy needed or looking at a sustainable way to provide energy isn't actually going to be the best solution anymore. Particularly when we compare 2000 to 2080, where we're seeing an increase of 46 to 80% needed for cooling loads. So if we're going to try and mitigate and have less of a sustainable impact on these climate risks in architecture, we need to actually address this from a different way. So if we begin to think about a building itself, the skin is the main area for exchanges of thermal control. And if we're in an ideal world, the best way to control thermal gain is by having a solid facade. But that's obviously not possible because architecture wouldn't be what it'd be if we couldn't actually break up the facade and have some sort of design, but also the need for windows for lots of different uses, whether it be user need or actually allowing for some solar gain. And often what happens is that we think about the climate as this kind of unified strategy. So we kind of see solar shading being the static solution, but actually we need to think about the building more so as an environment that is no longer predictable and actually creating a solution across the facade that potentially could allow for thermal gains to be more controlled in a responsive and adaptive way. So those words adaptive actually meant that I began to look at how we could look at lessons from nature. Adapting is one of the main criteria when we look at biomimicry, which is an established design strategy within the architectural field. But looking at that in depth, we can see that we take a lot of inspiration from lots of different animals in order to actually transfer what animals do to deal with thermal control into architecture. The way that we do that is by looking at the challenges that we're faced, and then looking at the adaptation, action, and morphology that's found in nature in order to form the design. And this is the kind of framework that Linda Bedhara developed within her own thesis of biomimicry. But when we look at that further at an organism level, we need to actually consider the different mechanisms that the animal is undertaking in order to then transfer that into a framework that can be applied and generated into architecture, whether that be form, process, function. But what the difficulty is with this current framework is that it currently is inaccessible or underutilized within actual design. And I think that we often find that in studio or within the actual architectural profession, we would never consider using biomimicry because we don't actually know how to apply it or utilize it, which shows a kind of massive gap in a potential framework for us to begin to actually implement nature and learn from nature at a greater length in order to deal with these climate issues that we've just highlighted. So then what we really need to do is accept adaptation within architecture. So this is where the paper kind of began to develop. So we began to look at the link between architecture and nature, but then kind of tie that in with the need to control thermal gain in a very unpredictable future for the UK, and then review biomimetic facades that potentially could be able to deal with that. So looking at the way that we're transferring from nature across that framework in order to look at the application of those principles in real life. And that would hope in a way to be able to begin to kind of see that, allow us to see that missing link and allow us to draw conclusions on how biomimicry and how we can begin to take nature and actually apply it within design. So what I began to do was set a framework of looking at how we could take maybe case study examples in order to derive these kind of links and actually then make the learning from the case studies a lot more impactful in the way that we go forward. So from my criteria set, I ended up getting 20 different case study examples, and then it was about establishing how we can learn from these case studies. So I'll take you through one example, which is A3, which is Al Bahar Towers, which was in the Middle East, and it was built in 2012. And I actually looked at the white butterfly, which uses its wings angles to be able to control thermal gain into its body, and that developed into kinetic facade. And that kind of is from the surface all you learn, but actually what was the connection, what was the derivative between a white butterfly and a kinetic facade is actually the key for us to actually be able to begin to learn from nature more properly. So what I began to do then was look at how I could create my own catalogue of information or a design matrix, which you can then begin to record all of the information from these case studies and begin to implement a real depth of learning. So we're starting off with criteria 1, which is building description, which is just giving the background information of the typology and looking at the materiality when it was built, the architects, etc. That then allowed me to then look at the location evaluation, which then allows you to understand why the building needed this kind of response. So we're seeing temperatures of maximum, 52 degrees in the summer. So we're needing it's a lot higher than the UK, as an example, but they're still having to deal with these climate extremes. So the suggestion is that they need something that would be able to cool the building or respond to those temperature highs. So then we begin to think about the actual animal, so in this case a white butterfly, and looking at delving into the research of how it uses kinetics and reflective qualities in order to allow for its heating and cooling strategy to take place. We then look at then how that's been implemented across the framework in order to design the facade. So by taking the materiality, construction and function qualities of the butterfly, you're able to kind of create this kinetic and reflective and shelter-like quality of the facade, which will allow the building to then allow to create this heating and cooling effect, which is more adaptive and responsive. So in this instance, they use kind of photovoltaic receptors on the facade, which allow them to open and close like the butterfly wings do in order to cool the building when it's needed. Which then when we look at how much it's then been able to reduce the efficiency, we can then look into different types of research into how we can then control, look at how it's reducing or creating the amount of kilowatt hours used, or looking at how it's actually being able to create a certain extent of coverage of the facade as well. So then when you then begin to look at that as a whole, you've then got this kind of breadth of information which allows you to kind of go from nature to application and also understand the efficiency of that kind of case study. So then the link itself is actually then understood, and we can see how we're taking the principles, the kinetic principles of a butterfly, implementing that into design and actually getting a solution that works. And what I did then was then take that kind of strategy and apply it across all 20 different case studies, which then kind of then gave a real kind of breadth of information, which allowed me to then do a lot of different analysis. So whether I could look at natural mechanisms and how they're being transferred into common climates or common organisms that are inspiring these facades, or looking at the implemented mechanisms, and again, looking back at the common framework and looking at the commonalities in the functions, or even the way that they're transferred between nature and the implemented mechanism. I could even tell you what the greatest architect is and tell you that the majority of the facades design came from plant cells. So my initial thoughts from this stage 1 study was then to kind of then take it to stage 2 and take those principles and kind of put them in a simulation that would look at the kind of way that they would be applied across the UK. But actually, I had to take a step back and think about that there was actually a lot of unanswered questions from that stage 1 of the study before we could even go into starting to do this kind of modeling data. And if we take our hard towers as that example again, I know that it's a biomimetic kinetic response now, and I know the response is about varying climate extremes, that to deal with the 20-degree external extreme temperature differences from internal and external, and is able to do and control that kind of temperature with a 50% reduction in kilowatt hours per meter squared. But what I don't know yet is the impact on the internal lighting, the impact on embodied carbon, the impact on materiality and construction, and also the renewable outputs. And those are all different qualities that people would also consider when thinking about sustainability. So that was kind of the question mark about stage 2. So what I began to do is then look at different types of kind of frameworks for sustainability, and I selected a few more to kind of evaluate that related to facades. So looking at energy use, waste, water use, etc. And from that, I could then reevaluate the Albert Towers on another metric, ranking it in comparison to the UK average, to the average of that case study, and see how it kind of comparatively is either achieving or underachieving on those different metrics, which then we then begin to plot across this kind of diagram here. You begin to see the strengths and weaknesses of a facade, which gives a much better picture on how actually the lessons from nature are implementing a facade design that can be sustainable and deal with these climate issues, and give a more resolute kind of understanding to that. So if we look at the conclusions of the case studies in general, I understand stage 1 and stage 2 as these, which then allow the solution, and this kind of methodology has come into place, which people can begin to follow in order to understand and learn about biomimicry. But what I'm yet to know is stage 3 is actually beginning to implement this new framework, this new kind of way of looking at nature through this step-by-step process that I've curated, and actually using it to design something. But there's also the potential to look at it and think about analyzing across more sustainable principles, or going on to that next stage about system modeling, but this is kind of the next stages of the research that I imagine was going forward. But the kind of most exciting part of this research has been the biomimetic matrix and catalogue, which can be used as this educational tool, allow us to kind of follow the same methodology in order to deal with other types of sustainable issues. It also can be used to evaluate other kind of issues that we're facing in architecture, whether it be urban biodiversity, which is something that I'll come on to in just a short second. And then finally, looking at further research. So I want people to be able to take my research and delve on it further. We could begin to actually take just another single case study and begin to evaluate that again much further, or begin to kind of analyze the data. Again, I looked at the data before and told you that I could tell you what the greatest architect was based on the data I collected, but is there more that could be taken from that data and learned from and analyzed further? Or could someone replicate the same thing? There's this wealth of learning that's been set from this dissertation that I hope that people can take forward. And I'll show you one way that I've managed to take it forward post-dissertation, where I began to think about my own design project, which was about addressing urban biodiversity. And I actually adapted this methodology in order to inform the way that my facades could become more integrated with nature and a more sustainable, biodiverse focused future. So I began to take a case sample of different animals that were in my landscape, or part of this kind of institute that I was creating, and began to break it down exactly the same way, which allowed me to design different types of livable facades. And these livable facades went on to create this kind of catalogue of facades, which could, one, help to reduce the amount of material that we're using, help to improve urban biodiversity net gains. I think I did a case study example in my project as well, where I implemented these facades on an existing building, where I was able to increase the biodiverse net gains by 600% by simply implementing the correct facade onto the case study, which then allows you to create these kind of cohesive projects which feel at one with nature and allow you to kind of fully understand the responsibility of architecture as this kind of forward-thinking duty of care to not only people but the world itself. And I think that this paper just kind of begins to scratch the surface of what the kind of framework that I set is capable of doing.